Welcome to Summarize Science, where we dive into the latest breakthroughs in technology and robotics. Have you ever wondered why robot hands often look so clunky when trying to pick up small objects? A major challenge in robotics is contact-rich manipulation, or the ability to handle objects with the same dexterity as a human hand. Researchers from Zurich and UC Berkeley have recently released a paper that might have found a better way for robots to feel the world. Usually, scientists use computer simulations to train robots before letting them try things in the real world. However, simulating the sense of touch is incredibly difficult because real-world sensors are messy and complex. Many current methods oversimplify touch to a simple yes or no contact, which isn't enough for delicate tasks. The researchers introduced a new representation called center of pressure, or COP for short. COP summarizes complex sensor data into two main parts: the direction of the force and exactly where the contact is happening. This creates a middle ground that is simple enough for simulations, but detailed enough for real-world control. To make this work, a new calibration scheme was developed that helps the robot understand its own sensor layout without needing expensive equipment. By using differentiable dynamics, they can estimate how sensors are oriented just by watching how the robot moves. They tested this new method on two very difficult blind tasks: inserting a peg into a hole and balancing a ball on a plate. In the peg and hole test, the COP method allowed the robot to adjust its grip and find the hole even when it started in the wrong position. Other methods often failed these tests because they couldn't interpret the subtle physical signals from the sensors. When it came to ball balancing, the robot showed an amazing ability to stabilize different types of balls with varying weights. The robot had to rely entirely on its sense of touch because it wasn't allowed to see the ball with cameras. The results show that the COP method outperformed both oversimplified binary touch and raw, unprocessed sensor data. Interestingly, the researchers found that the robot's control system began to understand the weight of the ball as a byproduct of learning the task. This suggests that providing better touch data allows robots to naturally learn physical properties like mass. Even when some of the sensors were intentionally hidden or masked, the robot remained surprisingly robust. So, what does this mean for the future of robotics? To recap, this research provides a way for robots to communicate tactile information in a language that works in both simulation and reality. It moves us away from binary touch and toward a more nuanced, physics-based understanding of interaction. In the future, this could lead to household robots that can handle fragile dishes or medical robots that perform delicate surgeries. The ability to feel without seeing is a fundamental skill that will make robots safer and more capable. While there are still limitations, like dealing with friction, this is a massive step toward human-level dexterity. Thanks for watching Summarize Science, and stay tuned for more fascinating updates from the world of research.